Welcome back to Inside the Forge, a video series that goes behind the scenes of Warwood Tool, one of America's oldest tool manufacturers. For over 172 years, Warwood Tool has been built on forging steel by hand. But staying American-made doesn't mean standing still. To keep making the tools that America's toughest jobs rely on, and to support the equipment that makes them, you have to be prepared for what comes next.
Our CNC lathe is really special because it lets us produce ironworking pins that we've had for decades, but they've always been forged. And so now with this, we've got the capability of making them at a far tighter tolerance than ever before. Our broadhead bull pins are a great example of how the lathe really comes into play with production. We've got the perfect combination of forged tool on one end, but also precision alignment tool on the other end that we're turning on the CNC lathe. For us, we don't see it as one or the other, but rather it's a perfect combination of craftsmanship meeting automation.
Well, the CNC mill helps us use a pre-calculated model and build everything off of that so that it's also able to be reproduced. It helps a lot when you're doing a resync. Once you set it up one time and spend the time to set up your entire model and program, after that it's repeatable. It's a robot. Well, some of the equipment is out there, it's been in service for years. It starts to wear out, it gets old, it's metal, or we're hammering hot steel together. So as it wears out, we have to go back and do a resync or, kind of hone back in the tooling that what it originally was. So in conjunction with the CNC machine, that's how we do it. And it'll recut and we resurface off, and that'll allow the tool to be back to new and be in tolerance. For new products, usually starts out with a design meeting and what we want the tool to be, what we want it to do in the end. Once we start the design of the tool, we kind of reverse engineer from the tool back through all the hammer dies, the trimmers, the punches, and everything that goes into making that tool. And then we start breaking it down into each individual part, starting with our stock, and then we machine it all and design it and machine it all. With all of our old dies and existing dies, over the years, talking over 150 years of dies and just random tooling that had no drawing to start with in the beginning. So how we utilize it is we take a 3D scan of something that's existing, and then we put it in the computer and we match. From there you can get dimensions and solid models and everything, and you can calculate volumes for steel and all that. And that is what it's really the importance of it, because we can go and take something that's old and, put it in using new technology. We could go back in and kind of resurface those 3D surfaces, which is one of the hardest things to do machine-wise, is getting an accurate 3D surface. So when we scan it, we can then have something to reference off of and match it and hopefully improve it and make it better, which we usually do.
The scanner puts a bunch of points onto the product, and then we kind of go through and take out the points that aren't needed and mesh ones here that are. And it gives us a good solid product of what it actually looks like and what we want to shoot for. So we can put it into our program and base everything off of that.
Our CNC machine shop's been absolutely amazing in keeping this old shop alive, because at the end of the day, parts break and you can't find replacements, so we can make them ourselves, but it's also key to our future and innovating because we're able to produce all of the tooling in-house at just an incredible speed and precision.
Standing on the shoulders of giants, you take everything that you can learn from the models and from the scans and from how you actually see it working in progress, the human element of it. Ergonomically speaking, how does that tool get handled? How does a person hold it? And is there what worked, what didn't work? So you're learning off of that and those older processes, and you try to improve them, based using logic, basically using logic and engineering know-how, A CNC machine doesn't necessarily take someone's jobs or say anything like that. It's replacing an older manual machining style of actual machining. So you're doing all the same things, you're just doing it using newer technology, I mean, a mill's still a mill, still using the same type of tooling. Some of it's a little more updated, cut at higher speeds, higher RPMs, that's what these do. And it's more controlled because a human just simply can't be traveling at, 100 inches a minute and making sharp turns and making every step accurate to, 5 thousandths or thousandths or half a thousandth of an inch. So that's where it's supporting us, because now we can make those paths and then make them, reproduce them. As far as the machinery or the tooling that you're making, when it goes out there onto the floor, the better product you give them to start out with, they will figure out, and they do figure out, how to get it made. And they can also communicate back with us, tell us what we need to do or what they think we need to do to make their job easier, to make the part better.
Future of Warwood Tool is highly dependent upon this new CNC capability, because it's what gives us the flexibility to bring in all this new stuff and find a way to make it work with our old equipment and our old processes.
Forging the future doesn't mean leaving the past behind. It means protecting it with the right tools, the right people, and the right capabilities. This is Warwood Tool, built on tradition, ready for what's next. Thank you for joining us for Inside the Forge. Make sure to subscribe to our channel, and if you enjoyed this video series, leave a like and a comment what you would like to see us do next.